Hello students. In the last episode, we were learning about pair of linear equations in two variables in which we discussed the graphical representation of linear equations. We also discussed about the three conditions when the system of equations have unique solution, when they have no solution and when they are coincident. In the same sequence, let us continue with exercise 3.2 question number 3. Here it goes. On comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the following pairs of linear equations are consistent or inconsistent. You remember, consistent we say when the pairs of equations have unique solution or infinitely many solutions, and we call them inconsistent when they have no solution. Okay, let us see the first part. 3x plus 2y is equal to 5 or 3x plus 2y minus 5 is equal to 0. We have written in standard form. 2x minus 3y is equal to 7 or 2x minus 3y minus 7 is equal to 0. Now let us compare these equations with general equations. A1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. We get a1 is equal to 3, b1 is equal to 2, c1 is equal to minus 5 and a2 is equal to 2, b2 is equal to minus 3, c2 is equal to minus 7. Now see the ratios. A1 upon A2 is 3 upon 2, B1 upon B2 is 2 upon minus 3 and C1 upon C2 is minus 5 upon minus 7, which is nothing but 5 upon 7. Since A1 upon A2 is not equal to B1 upon B2, the given equations intersect each other at one point and they have only one possible solution. So, the equations are consistent. Look into the second part. 2x minus 3y is equal to 8 and 4x minus 6y is equal to 9. Let us compare these equations with general equations. A1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. We get a1 as 2, b1 as 3, c1 as minus 8 and a2 is 4, b2 is minus 6 and c2 is 9. When we take the ratios a1 upon a2, we get 2 upon 4, that is nothing but 1 upon 2. Likewise, b1 upon b2 is 3 upon 6, which is again 1 upon 2 and c1 upon c2 is 8 upon 9. Just observe, we have a1 upon a2 is equal to b1 upon b2, but that is not equal to c1 upon c2. So, the given equations are parallel to each other and they have no possible solution. The equations are said to be inconsistent. Let us see into the third part, which says 3 upon 2x plus 5 upon 3y is equal to 7 and 9x minus 10y is equal to 14. We can compare these equations with general equations. A1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. We get a1 as 3 upon 2, b1 as 5 upon 3 and c1 as minus 7. What about a2? It is 9 and b2 is minus 10 and c2 is 14. a1 upon a2 is equal to 3 upon 2 into 9, that is 1 upon 6 and b1 upon b2 is equal to 5 upon 3 into minus 10, that is equal to minus 1 upon 6 and c1 upon c2 is minus 7 upon 14, that is minus 1 upon 2. Since a1 upon a2 is not equal to b1 upon b2, what do we have? We have unique solution here. So, the equations are intersecting each other at one point and they have only one possible solution. So, the equations are said to be consistent. Let us look into the next part. Here 5x minus 3y is equal to 11 and minus 10x plus 6y is equal to minus 22. Again comparing with the general equations, we have a1 is equal to 5, b1 is equal to minus 3, c1 is equal to 11, a2 is minus 10, b2 is 6 and c2 is minus 22. Look at the ratios. A1 upon A2 is equal to 5 upon minus 10, that is equal to minus 1 upon 2. What about B1 upon B2? it is minus 3 upon 6, that is again minus 1 upon 2, and C1 upon C2 is 11 upon minus 22, that is again minus 1 upon 2. So, what did you notice? A1 upon A2 is equal to B1 upon B2, that is again equal to C1 upon C2. So, in this case, the equations are coincident lines and have infinite number of possible solutions, and hence the equations are said to be consistent. I hope you have followed. Let us look into the next part now. 4 upon 3x plus 2y is equal to 8 and 2x plus 3y is equal to 12. On comparing these equations with the general equations, we have a1 is equal to 4 upon 3, b1 is equal to 2, c1 is equal to 8, and a2 is equal to 2, b2 is equal to 3 and c2 is equal to 12. When we take the ratios, we get 4 upon 3 into 2, that is equal to 2 upon 3, and b1 upon b2 is 2 upon 3, and what about c1 upon c2? It is 8 upon 12, which on simplifying we get 2 upon 3. So, we notice that here a1 upon a2 is equal to b1 upon b2, that is equal to c1 upon c2. So, the equations are coincident lines and have infinite number of possible solutions. Hence, the system of equations are consistent. So, students, let us look into question number 4 now, which says, which of the following pairs of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. That means we need to draw the graphs of only those linear equations which have solution. Let us see the first part. X plus y is equal to 5 and 2x plus 2y is equal to 10. We have a1 upon a2 is equal to 1 upon 2, b1 upon b2 is equal to 1 upon 2 and c1 upon c2 is equal to 5 upon 10. In this case, we have the equations are coincident lines and they have infinite number of solutions. Hence, the equations are consistent. Let us draw the graph. For that, we require tabular column. For finding values, x plus y is equal to 5, so x is equal to 5 minus y. For this, let me take the value of x and y. If I take the value of x as 4, look here, we have 4 is equal to 5 minus y, so y will be 1. When I take the value of x as 3, obviously the value of y is 2. And likewise, if we take the value as 2, we get the value of y as 3. For the second equation, 2x plus 2y is equal to 10, we can take x is equal to 10 minus 2y upon 2, and here on substituting the values, we see that as the lines are overlapping each other, the equations will have infinite number of solutions. We can see here the values are same, 4 1, 3 2 and 2 3. This has happened because you just observe the equations. X plus y is equal to 5 and 2x plus 2y is equal to 10. That means these two equations are equivalent. That is why we have same solutions here. Look students, we have taken the points here for x and y corresponding values 1, 4, 2, 3, 3, 2 and 4, 1. We have plotted here, see this is 1, 4. Likewise, this point is 2, 3 and next point here 3, 2. This point is 4, 1. And by joining these points, we get the graph of these linear equations. X plus y is equal to 5 and 2x plus 2y is equal to 10. We can see that the lines are coincident. Now, let us see the next question. In this, x minus y is equal to 8 and 3x minus 3y is equal to 16. Let us see the values. a1 upon a2 is 1 upon 3, b1 upon b2 is minus 1 upon minus 3, which is nothing but 1 upon 3, and c1 upon c2 is 8 upon 16, that gives me 1 upon 2. Now, since a1 upon a2 is equal to b1 upon b2, but that is not equal to c1 upon c2, what is this condition? It is the equations are parallel and they are parallel to each other and they have no solutions. Hence, the pair of linear equation is said to be inconsistent. So, we need not draw the graph here. Let us see the next part. So, let us look into the next part here. 2x plus y minus 6 is equal to 0 and 4x minus 2y minus 4 is equal to 0. We have seen that a1 upon a2 is 2 upon 4, that is 1 upon 2, and b1 upon b2 is 1 upon minus 2, and c1 upon c2 is minus 6 upon minus 4, that is nothing but 3 upon 2. We see here a1 upon a2 is not equal to b1 upon b2. This is a case of unique solution. That means the linear equations are intersecting each other at one point and they have only one solution. Hence, the pair of linear equation is consistent. In order to draw the graph, let us take out the points. We have here from first equation 2x plus y is equal to 6 or y is equal to 6 minus 2x. When we put the values of x as 0, we get the value of y as 6, and on substituting the value of x as 1, we get 6 minus 2 as 4, and on substituting the value of x as 2, 6 minus 4 is 2. So, these are the points we have got. Now, for the next equation, we have 4x minus 2y minus 4 is equal to 0 or y is equal to 4x minus 4 upon 2. Here again, when I substitute the value of x as 1, what do I get? I get the value of y as 0. On putting the value of x as 2, we get the value as 2, and on taking the value of x as 3, the value obtained is 4. It can be seen that these lines are intersecting each other at common point. What is that? 2 comma 2. You can observe here, we get common solution 2 comma 2. We have the graph here. In this, 2x plus y minus 6 is equal to 0. For this, the points plotted are, you can see 3 comma 0, then 2 comma 2 and 1 comma 4. We join these points, we get the graph of this linear equation 2x plus y minus 6 is equal to 0. Likewise, on plotting the points 0 comma minus 2, 1 comma 0 and 2 comma 2 and 3 comma 4, and we join these points, line of equation 4x minus 2y minus 4 is equal to 0. We also observe that the common point is 2 comma 2, that is the solution of this linear equations. Let us look into the next part. The fourth part goes 2x minus 2y minus 2 is equal to 0 and 4x minus 4y minus 5 is equal to 0. Here a1 upon a2 is 2 upon 4, that is 1 upon 2. b1 upon b2 is minus 2 upon minus 4 and that is again equal to 1 upon 2, whereas c1 upon c2 is 2 upon 5. So, we notice that a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. Thus, these linear equations have parallel and they have no possible solutions. Hence, the pair of linear equations are inconsistent. Now, let us look into the next question, which says half the perimeter of a rectangular garden whose length is 4 meters more than its width is 36 meters. Find the dimensions of the garden. Very interesting question. Here, let the breadth of the garden be x meters and let the length of the garden be y meters. Half of the perimeter is 36 meters. First, we note down what is given in the question. Then I know what is the formula for calculating the perimeter of a rectangular garden. It is 2 into L plus B. Using that formula, half of 2 into L plus B is equal to 36. This is the formula for perimeter. 2 into L plus B is 2 into x plus y in this case. So, I get x plus y is equal to 36. This becomes our first equation, and according to the question, length is 4 meters more than the width. So, y is equal to x plus 4. This becomes our second equation. In this, we will be calculating the points so that we can solve the question graphically. We have x plus y is equal to 36. Let us find out the points. if I take the value of x as 16, what is the value of y? It is 20. And if I take x as 0, y has to be 36. And if I take the other way, if it is 20, I get this as 16. Likewise, for the second equation, I have y is equal to x plus 4. Let us find out the points. If I take x as 2, I get y is equal to 6, and if I take x is equal to 16, y is equal to 20, and if I take here 8, what is the value of y? 8 plus 4 is 12, and if I take the value as 12, what is 12 plus 4? It is 16. Now, let us plot these points and see in the graph. We have also noticed that common point is 16, 20. That reflects that is the solution of this equation, that is x is equal to 16 and y is equal to 20. In other words, the breadth is 16 and the length is 20. You remember, length was 4 meters more than the breadth. So, we can see that 16, 20 is the solution of this equation, and the dimensions obtained are width is equal to 16 meters and length is equal to 20 meters. I hope you have understood this. Let us go into the next question. So students, let us look into question number 6 now, which says, given the linear equation 2x plus 3y minus 8 is equal to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines or coincident lines. So, we have the equation 2x plus 3y minus 8 is equal to 0. So, for this, let us look into the condition for unique solution. A1 upon A2 is not equal to B1 upon B2. In this case, 2x plus 3y minus 8 is equal to 0. We have taken the equation x plus 3y minus 10 is equal to 0. Look here, I have got A1 as 2 and A2 is 1, which is not equal to B1 is 3 and B2 is 3. So, we can see 2 upon 1 is not equal to 1. So, in this way we can get many examples and we can have many possibilities of framing linear equations to give us intersecting lines. Let us look into the second condition, that here we require parallel lines. What is the condition for parallel lines? It is no solution. A1 upon A2 is equal to B1 upon B2, that is not equal to C1 upon C2. Here the given equation is 2x plus 3y minus 8 is equal to 0, and we have taken a line which is parallel, that is 4x plus 6y minus 9 is equal to 0. Did you notice what we have done here? We have multiplied the coefficients of x and y with 2 and the constant terms we have taken differently. That means, we have taken 2 upon 4 is equal to 3 upon 6, which is obviously not equal to minus 8 upon minus 9. In this way, you can have many more examples and you can frame equations which give us no solution conditions. In the third case, 2x plus 3y minus 8 is equal to 0, I require a coincident line. It is easily obtained here. You see, we have multiplied this equation just by 2. And what is the condition we obtain? A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Look here, we have 2 upon 4 is equal to 3 upon 6, that is equal to minus 8 upon minus 16. Do you notice 1 upon 2 is equal to 1 upon 2 is equal to 1 upon 2. That means, we get here coincident lines because A1 upon A2 is equal to B1 upon B2, that is equal to C1 upon C2. I hope you have understood this. Let us go into the next question, which says, this is very interesting and very important question. Draw the graphs of the equations x minus y plus 1 is equal to 0 and 3x plus 2y minus 12 is equal to 0. Determine the coordinates of the vertices of the triangle formed by these lines and the x axis, and shade the triangular region which is formed by these lines. Let us first find out the points which we will be plotting for the graph. First equation is x minus y plus 1 is equal to 0. So, minus y is equal to, if I take x and 1 to other side, signs will change. Now, if I multiply throughout by minus 1, I get y is equal to x plus 1. Simple equation. Let us have a tabular column. Now, if I take x is equal to 0, y is equal to 1. If I take x is equal to 2, I get point as 3, and if I take 3, it is 4, and if it is 4, it becomes 4 plus 1, 5. Likewise, what is the second equation? We have 3x plus 2y minus 12 is equal to 0. In this case, we have 2y is equal to, we take 12 to other side, it becomes plus 12 minus 3x. Still we simplify this, y is equal to 12 minus 3x upon 2. Let us obtain the values to plot the graph. In this case, if I take x is equal to 0, what do I get? 12 upon 2 is 6. If I take 2, 12 minus 6 is 6 upon 2 is 3. And what is the next point? Let me take 4. It looks very simple. 12 minus 12 is 0. One more point we can take. Let me take as 6. And what is 12 minus 18? It gives me minus 6 upon 2, that is minus 3. Now, let us plot these points and see how the graph looks like. We have a beautiful graph here. By plotting the points which we had obtained, it is minus 1 comma 0 and it is 2 comma 3. Here it is 4 comma 0 and this is our x axis. Can you find the triangle formed here? We have also shaded the triangular region, because the question says you have to shade the triangular portion which is obtained along with these lines and x axis. We need to also mention the coordinates of these points. What is point A here? It is 2 comma 3. What about point B? It is minus 1 comma 0, and this is our point C. It is 4 comma 0. So, I hope you have understood how to plot the points. Now, it is time for our assignment. So, students, after finishing this exercise, I think it is time for taking down the assignment. Question number 1, it is, what is the condition for inconsistent solution? Next, find the value of k for which the system of equation x plus 2y is equal to 5 and 3x plus ky plus 15 is equal to 0 has a unique solution. Question number 3, find c if the system of equations cx plus 3y plus 3 minus c is equal to 0 and 12x plus cy minus c is equal to 0 has infinitely many solutions. Question number 4, draw the graph of 2x plus y is equal to 6 and 2x minus y plus 2 is equal to 0. Shade the region bounded by these lines and x axis. In this case, we have to find the area of the shaded region. Okay, I think you will try and you will be able to do it. So, students, in this pair of linear equations in two variables, we learnt in this episode how to calculate the solutions of the linear equations graphically. I hope you have understood. In the next episode, we will learn the algebraic ways of solving linear equations. Thank you.